This is Core Concepts Key Assessment 3, Paper 2, Question 2. Hopefully you've watched the Help Me video for a little bit of explanation on this. This is a model answer. Introns and exons. Introns are kept in, that's why I remember that, and exons are expressed into our protein. And the first point is explain the process of transcription, including the role of enzymes. So I'm going to talk about transcription and mention any enzymes that I can. So transcription is unwinding of this double helix, separating the strands, and then building a messenger RNA from RNA nucleotides using the enzyme RNA polymerase. That's basically what we're saying. So DNA unwinds or unzips. You can mention an enzyme here. It's actually helicase, although if you mention our RNA polymerase, that will get you the mark as well, because you don't really know helicase. And we are saying we're going to start building this messenger RNA. So complementary RNA nucleotides, and we'll mention base, using base pairing. So complementary RNA nucleotides are joined using base pairing and using the DNA template. So that's the code is being transcribed or copied. And then we'll mention the enzyme, which is RNA polymerase. A's enzyme makes an RNA polymer, joins the nucleotides. So that makes that sugar phosphate backbone. Why is it important that the RNA consists only of exons? Well, the exons are going to code for the protein. The introns could code for all sorts, but they would change the shape of this protein if they were included. So introns do not code for the primary structure. Only the exons code for this. Only the exons code. Or words to that effect. 2 marks, and that answers the question. So if introns are included, this would make a different protein. Make a different protein, or a similar protein with a different shape, or we could say a different shape, and give a different function, different structure. So not the protein that we want in. Explain how a change in sequence, the basis of a gene would affect if it was an intron or an exon. So the same sort of question really. If it's an intron, well, you can do what you like with those because it ain't gonna get translated. So intron, no effect. No, it's not translated. An exon could change this primary structure. So this could change the primary structure. Because we could get a different amino acid being coded for. So could code for a different amino acid. And indeed, when we go to the next question, here we go. We're getting just a more detailed view of this now. Using these lengths of DNA, complete the correct sequence of amino acids. So we're reading the messenger RNA, because that's our messenger RNA there. And we just need to go AUG, AUG, that's MET on that one. We've got UUU, UUU, CAG, CAG. We have got UGG, UGG, DRP, and we've got UGA, UGA, stop. Let's do this one. AUG, that's the same. UUC, that's different. U, C. Oh, haha, different code. That's a mutation, but it actually codes for the same amino acid. Okay. CAG, same. UGG, same. UG, yeah, that's the same. Yeah, so same amino acid sequence. Explain why the change of bases is shown as a silent, is described as a silent mutation. Well, we've got the mutation, but you would never know if you looked at the amino acid sequence. So this codes for the same amino acid. Can't spell acid, which is phe, aniline. So no change to the protein structure. Char graph kind of did the ratio of the bases. And we are being asked to calculate a ratio. Answer the question, 2 decimal places. Answer the question, human sperm. A to T. So 30.7 to 31.2. That's our ratio there. It's traditional to put something, when we're doing ratio, we do something to 1. So I want to make this 31.2 into 1. So I divide it by itself, and that would equal 1. And I'm going to do the same to the other side. So divide by 31.2. So 30.7 divided by 31.2 is 0.98 and change. And 2 decimal places, that's going to be 0.98. So 0.98. If you've done it the other way around, then you got, if you got 1.1 to 1.02, then that's fine as well. So you just done it the other way around. But traditionally, it's you do something to 1, something to 1. So again, G to C, we have got G to C, and I want to make this into something to 1. We have got 19.3 to 18.8. I'm going to turn that into 1 by dividing it by itself, equals 1, and I'm going to do the same to that side. So here we go, 19.3 divided by 18.8 is 1.0265 1.957. 2 decimal places, please. And so 1.02, but that's a 6, so it's going to have to be 1.03 to 1. 1.03 to 1. And again, if you did that the other way around, that would be I think 0.97. 1 to 0.97. So a little bit of maths, and then as a grand finale, we got 2 statements. One from Pauling, talking about this structure, DNA, as a possibility, and we've got Franklin, who sadly died before being able to be sharing in the Nobel Prize, stolen by Watson and Crick. They've got their Franklin's results there, and you just need to compare that to your knowledge of DNA. So you know it's double-stranded. So you know double-stranded and it's a double helix. You know on the outside we have sugar, phosphate, backbone, and you know in the inside you have got the bases inside. So that's your knowledge of it, and you just need to compare these two. So for example, Pauling says, so we are evaluating this, so do we agree or disagree? Do we agree or disagree with these facts here? So it starts off, sugar groups, it's unlikely that sugar groups are at the core. And are sugar groups at the core? No, they're on the backbone. So we could agree. We could say correct that sugar not at the core, because we know that the bases are. And so we've done sugar groups at the core. The core is phosphate. Oh, we had phosphate in 3 chains. Oh dear. Disagree. 3 chains. Well, we know it's 2. 3 chains. No, we know it should be 2, because 2 allows our complementary base pairing. Base pairs. That's how the information is. And we talked about this 3-chained, and then we've got purine and pyrimidine on the periphery. Nope. The core is phosphate, so disagree. Core is phosphate. Yeah. Should be on outside. We could disagree again. Purine, pyrimidine on I can't spell periphery. Periphery should be on inside. So agree with 1, disagree with 3, and we're doing the same for Franklin's. We've got helical structure, 2, 3 or 4 chains, phosphate on the outside. Okay, this is better. So we are saying that it's 2 chains. So correct, agree DNA is helical. Okay. Two chains. Disagree with 3 or 4 chains, because we know it to be 2 in our current understanding. We're going to, phosphates on the outside, we're going to agree phosphates on the outside. And so, evaluate how close to the suggestions. We're going to say that Franklin was the closest, so Franklin closer to modern knowledge. So we're actually answering the question there. So quite a long question for 15 marks. Hopefully you're okay with that.